There we go. This symbol here is the population standard deviation. It's called sigma. It's got a special name. Now, sigma, I'm going to represent it as, we'll go over what sigma is later in much more detail, but it's kind of it's a relatively complex thing in statistics. So sigma is basically what the range of values are in your population compared to the average. So if our values were like this, 1.5, 2, and 2.5, our sigma, or our population standard deviation, would be lower. And this is because the average of this should be what? 2.5, 5, and 4, 7, so what's that, 7 over 4? So that's equal to 1.75 meters. The reason why sigma, or the population standard deviation, is lower for this value is because the values of height cluster more closely around the average. You'll notice that the difference is much less. So 2.5 minus 1 is equal to 1.5 in difference, but 1.75 minus 1 is equal to 0.75. The values are closer together. And I'm going to quickly draw you two normal distributions. These are going to be something you become very familiar with, and if you don't, you will probably fail this course. So this one here might be the normal distribution for the first one, where this value here is equal to 2.5 meters. Cool. And then you might go out a bit, and it's like, oh, look there. So we've gone up. We'll say that this is 3. You want to go up again. We'll say this is 4. Now in this case, because our standard deviation is smaller, what you'll notice is this. Notice that it's much steeper. This is 1.75. And when we go up much less, because our values are closer. Oh god, that's terrible. Because our values are much closer together. So this here might be 2, for example. And then this one here will be, what, like 2.5. So because the values are closer, the spread of the data is less. And that's really the concept you need to get across. When you have a larger standard deviation, you expect more variability in the population of interest. Now the other thing, we're going to go with pink this time. Oh no, we've already gone with pink. We'll go with dark cyan. Yeah, like a, what is it called? Like a teal, is that right? The other value is S. It is I'm going to go over this very quickly. It is exactly the same as this, but relates to sample information. So it's the sample standard deviation. It is the estimation of what the population standard deviation is likely to be. There's another rule, is this value here will always be greater than sigma or equal to sigma. It will never be less than, because in a sample, because you don't have the population information, you have to make assumptions that the variability is greater, because you don't have the information about the entire population. You just have enough to make an inference about what the information in the population is.